In this video, we're going to look at two examples dealing with the application of slope as well as using the y-intercept in an application problem. Recall, slope-intercept form is y equals m times x plus b. So m, that coefficient multiplied by x, represents slope, and then b represents the y-intercept. Couple of things that we want to think about. Slope represents a rate of change, and then a y-intercept is a fixed amount. Let's look at our first example. For this example, we're given a word problem. We have that the U.S. annual per capita consumption of broccoli was 3.1 pounds in the year 1990. However, by 2008, this amount had been rising or increasing to 5.5 pounds. Let's find the average rate of change in the pound consumption of broccoli per capita over that period of time from 1990 to 2008. So when we're dealing with a word problem, the first thing we always want to make sure we look at is, determining what we're being asked to find. Here, we're being asked to find the average rate of change. And the average rate of change means we need to find the slope. So in order to find slope, we need to know what's required. And as I've written here, in order to find slope, we need 2 points or 2 ordered pairs, or rather 2 pieces of data that create ordered pairs. So let's look at what we're given. The first piece of data is we know that there were 3.1 pounds annual per capita consumption of broccoli in 1990. And then our other piece of data is that by 2008, it had gone up to 5.5 pounds. So we can create 2 ordered pairs. Now, when I look at this problem, and I'm trying to figure that out, which piece represents x and which piece represents y in each of these ordered pairs, one thing I think of is that time is generally x. So my x value is going to be years and my y value is going to be pounds. Now, it's not always the fact that time is x, but generally your time value is x. So we've got time a year, pounds being that quantity of broccoli. So my first ordered pair will be 1990, 3.1. And my second ordered pair is going to be 2008, 5.5. So I have 2 points here, and I can go ahead and plug both of these into my slope equation. However, we're going to do one extra step, which in this case, if you didn't do it, you might still, or you actually would still get the correct answer, but depending on how elaborate the problem is, you really need to do this next step, especially if you're writing the equation. So what we have here is we have that in 1990, 3.1 pounds were consumed, and in 2008, 5.5 pounds were consumed. Well, we're going to let 1990 be year 0. So I'll say 0, 3.1. And then 2008, well, that is 18 years past 1990. So we're going to call that year 18. And we'll use 5.5. So now when I go to find my slope, remember slope is change in y, that delta symbol means change in y over change in x. Or in this situation, 5.5 minus 3.1 divided by 18 minus 0. 5.5 minus 3.1 is 2.4. I have 2.4 over 18, or 2/15. That is our reduced fraction here. Now, because this is an application problem, Our answer needs context. So let's think about what was the unit on 5.5 and 3.1. Those represented pounds. So this is 2/15, 2 pounds per each 15. 15 what? And 18 and 0 are representing years. So if I take that 2/15 and plug that into my calculator, I get a decimal which does not terminate, 0.133. We get a repeating 3 there. So that is pounds per year once we divide that out. So is the per capita consumption increasing or decreasing? Well, looking at the problem, it said it had risen, but this should make sense because we have a positive slope. So we could even further write this out as a sentence. We could say it's increasing at about 0.13 pounds per year. Right, so the consumption is increasing, and that should make sense because, we are learning more about health and we are becoming healthier people. So we know we need to eat more broccoli. All right, let's look at one more example. For our second example in this video, we're going to look at this application problem. Time Warner Cable charges a $95 installation fee and $125 per month for the deluxe plan. Let's write a function that can be used to model the total cost, C of T, for T months of service using this deluxe plan. And then let's find the total cost for 18 months of service. So let's look at what we're being asked. We're being asked to find two things. First, we want to write a function that models the total cost for T months of service. And then we're going to determine that total cost for 18 months of service. All right, so we want to write a function, and so far we only know about lines or linear functions. One thing we know about lines, the standard form is going to be y equals mx plus b. That is our slope-intercept form. M, of course, is slope or rate of change. And then B represents the y-intercept or the fixed amount. So let's look at what we're given. Well, we have a $95 installation fee and $125 per month. Now, the $95 installation fee, that's something you're just going to pay once when the guy comes out. That's a fixed amount that you have to pay no matter what. So B is 95, and the rate, my slope or my rate of change, is going to be 125. So we might write this as y equals 125x plus 95. And that's perfectly acceptable, but this problem is specifically asking us to model the total cost, the output cost, C of T, given some input, T months. So we need to write this a little bit differently. So my input variable, time, is T. And the way we would write this is C of T, the total cost, is $125 times T per month plus 95. And it's kind of easy to think about that as being a balanced equation because it is dollars per month times month plus dollars. If we think about canceling, then we would end dollars plus dollars. That makes sense that my output is cost, dollars only. However, this is the function that we would use to model the total cost. And of course, finding that total cost, we would just plug in 18. So we'd have C of 18 equals 125 times 18 plus 95. Simplifying that, C of 18 equals 2,345. So what that means, reinterpreting this in an application sense, is the total cost for 18 months of service is $2,345. So when you're writing this, if you're writing this out on a test, you wouldn't need to write that whole sentence, but you do need that dollar symbol to say that, hey, this represents a quantity of money. But when we're trying to understand these problems, it really does make sense to write the whole sentence out. So the total cost, again, for 18 months of service is $2,345. And if we were asked to find the total cost for 2 years of service, if I said 2 years, what would we plug in for T? Remember, T is in months, and 2 years would be how many months? 24. So always paying attention to those units. Everything has to be in the same. So if this said 2 years, we would need to plug in 24 months because my rate is per month. So that concludes this video where we talked a little bit about slope, understanding it in an application context, as well as that y-intercept or the fixed amount. As always, feel free to contact me with any questions or concerns because I am here to help. You are not alone in your algebra journey.